Can you see my presentation? Okay. So, good afternoon, everybody. So, I'm Stefano Puri from Intex, and I'm going to talk about a few slides about the SafeCer project. So here I'm going to reuse the slides prepared by ATMDH and presented during the SafeCer final open workshop. So I just go through only through a few of them. So according to agenda, I have only 5 minutes for this presentation. So I will give you only the main information about what SafeCer was about and the general approach. So SafeCer was a 4-year project and was ended last year. And our objective was to reduce the cost of qualification, certification, and verification, and to provide a framework for compositional development and certification of systems. And the main idea was to reason and extend the existing process and technology in order to allow composable qualification and certification of system. So the main idea is to qualify or certify system, subsystem, or components, starting from the properties of internal entities. The project targeted the main industrial domains, in particular automotive, construction equipment, avionics, railway, and healthcare and cross-domain. This slide is about the techniques that has been elaborated and in the project. So, as I already said, the main approach is the composable certification, also called the in SafeCer co-certification. Composable certification is can be applied by using different features, particularly the development, different steps. Particular development, verification, and argumentation. For what regarded development, in SafeCer we elaborate and extend a specific the concept of process, development process, in order to introduce process steps that are needed for in order to integrate the development and argumentation concepts. And then, still for the development phase, we elaborate and define a component model. Which to be used to implement the process. And in the component model, as we will see later, we elaborated on the concept of safety contract and composable assumed guarantee reasoning. Then in the process, during the SafeCer project, we elaborate about the concept of argumentation, in particular about the concept of composable safety argumentation and evidence. Then, in order to support the combined certification process, we addressed the investigation of new and extended verification and validation techniques in order to support the composable certification, in particular in order to provide composable result of these verification and validation techniques. In SafeCer, we also investigate some tool support in order to better provide the topics that that we have seen in the previous slides, and maybe you have already. Well, some of you already are aware of the fact that in SafeCer we had two. The objective was to develop a specific technology, namely CTF and CAR, and maybe as you know, this CTF and CAR results are not provided in AMASS. Will not be provided in AMASS project, but we have other technologies, for instance, provided by AT that allows to, for instance, provide traceability of information and checks about the process compliance. So we have an alternative for these tools. As already said, the SafeCer project is then in the SafeCer project we covered different domains. So we demonstrated the result and evaluated the approach. So I will stop here for the process presentation, because I think we can go into the details of the results in the following presentations. So if you have not question, I can switch directly to the next presentation, which is about the SafeCer component model and also the CHESS approach.
I have a question. You said
yes.
that the tools, the CTF and CAR, they are not going to be part of the AMASS project. It won't be the background to be included.
Yes, right. Because we think that the results that was obtained in the SafeCer project are not so, I don't know how to say, but we think that it was not sufficient or enough results about these two technology in order to elaborate some improvement or some adaptation in other frameworks. I don't know the opinion of the others, but we have alternatives in order to provide tool support for traceability or process compliance, consistency, and we think we can go with other solutions.
Okay, it was just to clarify it. Okay.
Mm-hmm. I don't know if the other SafeCer partners want to add something about this aspect, because I understand that this was something that SafeCer had an important role, but I think that also. I think it has been also discussed during the AMASS proposal that this CTF and CAR will not be introduced or added as a baseline for the AMASS reference to architecture.
Okay, well. From FBK, I can confirm this view. The CTF and CAR should not be part of the AMASS as we discussed during the proposal. And since it's recorded, we cannot add anymore.
Okay. So if there's no other question, I can proceed with the other presentation. So about the component model. So here again I use a presentation that we made for the final open workshop on SafeCer. So the slide was prepared by me, Silvia, and Jan from MDH. So I've already introduced you the concept of SafeCer component model that in SafeCer was meant to support the composable certification approach of SafeCer. So in particular, in order to have the possibility to model the architecture, architecture of the system, together with the argument safety related safety properties. SafeCer component model is a generic model, so is I would say a cross-domain component model, which has been defined in order to possibly instantiate in different domains and in different existing component model. Okay, SafeCer component models provides, for what regards the architectural parts, provide the concept and relationships that are already available in commonly used component model, and moreover, it puts some extension and by defining specific entities for the modeling of safety contract and safety argumentation information. So we're going to talk about the component model definition, and we'll use basically the diagrams that rely on the UML syntax. So if you have a question about it, you can ask me, interrupt me. And okay, so we can start from definition of the main entity, I would say, which is the component type. Which is intended to model a software reusable, replaceable entity in a given reusable, replaceable in a given system. So the component type is a software entity which is modeled and defined out of a particular context. So according to the approach designed in SafeCer, the idea is to start modeling components out of context with all the information about the functional and extra functional property, particularly regarding safety property, and then trying to obtain the system by combining existing component and obtaining the safety property of the system by reusing and merging the safety property and argumentation of each of the single component. And so the entity that we have modeled for the are available for the component are the entities that are quite that you can find in all the component model languages. So here we have defined that the component can have ports. So this is important in order to be able to model a component of the context. So each port represents a specific interaction point. And then the component can have some configuration parameter in order to model some variability in its functional dimension. Then we have the concept that the component, a software component, can be decomposed in subcomponents, where subcomponents can be seen as an instance of a particular component in the context of the parent component. So, for instance, here you can see that a composite, a subcomponent, which you can think that this is an instance can have some value for the configuration properties we have seen before, in order to fix some variability that has been provided through the configuration parameters of the components. And then the subcomponents inside the given component type can be connected between them by using the defined ports. In the component model, we define the concept of system, which is basically the system under design, which is made by the software, the hardware platform. We also address the fact that the system can be modeled at different abstraction layers. So, for instance, the system at a higher abstraction layer, for instance, can be defined as a collection of functions, where each function can then be realized by a given component. Here, in this slide, we see that actually here we are talking about, when we talk about component system, we talk about component instance. So, as I said before, the system is designed by reusing existing component defined out of the context. So, in order to build the system, you take the component type, you instantiate it, and you connect the different instances together, and in order to build the software for the given system. And then also we have the possibility to define the platform, the hardware platform, and the allocation of software to hardware. So this is so far I have added information that I have introduced information that is basically available in a standard modeling language like UML or SysML, for instance. Here in this slide, you can see the parts that regards the support for contracts and argumentation. So again, the main entity here is the component type. And the idea is that for the component type, we want to provide safety properties for it. And the safety property for the component type can be expressed by the concept of contract, where the contract is something structured in terms of assumption and guarantees. In SafeCer, we made a distinction between a strong assumption, contract and weak contracts. So regarding strong contract, if a component has a strong contract, then when you instantiate a component in order to be able to instantiate a component in a system, the strong assumptions must hold in order to use the component. So the assumption make some constraint about the environment where the given component can operate. So if the assumption provided to the contract are not satisfied by the given environment, then the component cannot be instantiated in that environment. If the assumption holds, so if the environment fulfill the assumption, then it is possible to rely on the guarantees that are part of the component contract associated to the component type which is instantiated in the system. And so the guarantees can be relied and maybe made part of the, for instance, safety argumentation. Well, for the weak contract does not have this as different meaning. So a component have a weak contract can be placed in a given environment, even if the weak assumptions are not guaranteed by the environment. In this case, so if the environment are not able to satisfy the weak assumption, then in this case I can instantiate the component in the system, but I cannot rely on the weak guarantees. So the weak guarantees are discarded. Okay, and then we have the concept here of argument fragments. Argument fragments, which is basically representation of evidences that safety goal is met, and the reasoning why these evidences can be trusted to fulfill a given safety requirement. And so the argument fragment can be attached to the component in order, for instance, to elaborate on a given safety requirement, or can be attached to a given component. In this case, the argument fragment gives the idea about how the component contracts, in particular the guarantee, can be trusted. Okay, I think...
There's just a question regarding that
yeah.
property, because I see one of the parameters is the integrity level. So
Yes.
can we have like an example of this to be easier to understand?
Integrity level, yes. We put integrity level here in order to provide information about the confidences or confidence of in the contract. So the strength of the argumentation, why the component can be trusted to fulfill the contract. So if
will it be something like for this component I associate it with an ACLD, and that will be that integrity level?
Yes, ACLD for the, actually yes, if you associate to the contract, it gives you an idea about how you have to provide arguments and evidence about how the component can fulfill the guarantees that are specified by the contract.
And what about properties such as, for example, availability? Would that be, how would that be modeled?
The availability would be, yes, could be modeled as a given property or as a guarantee of a given contract based on some assumption. And yes, so it could be provided, I think, as in form as a contract for the component, if possible. Is this answer your question, or?
I will see if later with some examples and instantiation of this model, I can understand a little bit more. Thank you.
Okay. Okay. So I think I have to, maybe I can skip this because I have already explained the details. So basically this it's all about the SafeCer component model. Maybe here I can now switch to the CHESS, which is part of the second part of this my presentation, where so I have already introduced a CHESS during the kickoff meeting, and maybe we will have a dedicated training session for CHESS. So just to briefly remember, the CHESS is a model-driven methodology for the development of software system. So we basically provide a component model and a methodology about the usage of this component model and some model-to-model, model-to-text transformation in order to perform verification and code generation. Here, for instance, you can see. So the CHESS component model was extended in the SafeCer in order to be able to act as an instantiation of the SafeCer component model. So here, these slides, for instance, you can see a possible modeling of the contracts in CHESS. Here you can see in CHESS contracts as a kind of constraints that compose it in the sub-constraint about the assumption and guarantees of the contract. And then it's possible to instantiate the contract in the component on the system, also in this subsystem, and in order to constraints the definition of the components and the blocks. And so we support different modeling steps. And also in SafeCer we added the possibility to integrate with the OCRA tool from FBK in order to perform some formal verification from this contract. About this verification we will see in a presentation later. So the idea is here in CHESS is to use is to cover all the process steps foreseen by the SafeCer Process, which beside the standards process steps foreseen other process steps for the contract definition and also certificate argumentation preparation. And so our approach is to use this tool in order to support all these steps. Okay, then we had feature works in order to extend, make more formal reasoning about the contracts and the argument fragment, and so this is something that I think is we also is very interesting in AMASS. So I think this is all for my presentation. I think my time is over. So
yes,
if you have a question, otherwise we can switch to the next.
Okay, if there are no questions, then we can continue. Okay.
Hello?
Yes?
This is Wesker. Just to understand your approach for implementation this meta model, what I understand is that this meta model is your conceptual model, right? It's not what, the way you exactly you implement it. Because you say that you implemented chess, and I understand that chess is based on Papyrus. Papyrus use the profile mechanism.
Yes, right. In fact, they say the SafeCer component model is a representation of the information needed. Then, in order to work with it, yes, we rely on existing component model. For instance, the one we have in chess, which that has been extended. That is, as you said, is based on UML, UML and other profiles. And also other component model were used in SafeCer in order to directly use the SafeCer component model.
So, for instance, in chess, or the way you use chess in SafeCer, have you extended the existing profiles? You say that you are using Marte profile.
Yes.
XML, but Marte. Have you extended Marte? Have you modified these profiles, or how, or the existing profiles are okay for you, or cover your conceptual model?
We have actually we have extended the SysML profile in order to model the concept of contract. We have this proposal, and so we didn't find a support from the existing standard about the notion of contracts. Maybe Marte has something, but very poor. So we decided to basically mimic what is already available in SysML regarding the constraint block, and we extend SysML in order to have a constraint block, which is actually a contract.
So you used SysML with some extension.
Yes.
Okay, and this specification of your implementation are available somewhere open, or?
Yes, I can give you the deliverable of SafeCer which are about the component model instantiation, which are public.
Okay,
I can provide you. You're welcome.
Okay, if there are no more questions, then we can start with the next presentation.
Yeah, sorry, I've stolen too much time, I think, so sorry for the other.
We continue. So the next part, let's see. Do you see the presentation?
Yes.
Good. Okay, so this one I'll present. My name is Irfan Sljivo, and I'll present this work on enabling generation and reuse of safety argument fragments via weak and strong contracts. We've already heard the introduction of some of the notions here, so weak and strong contracts and argument fragments and so on. So we focused mainly on how to achieve reuse here of safety artifacts. And when we look into the standards, we see, for example, in these two standards, ISO 26262 and DO178BC, there are different notions for reuse that help us to achieve reuse of safety elements. In ISO 26262, we have safety element out of the context. And in our work, we focused mainly on this concept. As we know, reuse within safety critical systems covers mainly code, and our idea is to achieve reuse of safety artifacts together with that code. So, such as safety argument fragments or supporting evidence and so on. If we take a look at the example that we worked on during within SafeCer, safety element out of context within wheel loaders. So we had a family of wheel loaders, and each of those wheel loaders has this lifting arm that can perform up and down movements to move load and so on. Because it's a great family of products, these products work in many different environments and have many different safety requirements associated with them. So we considered the use of this lifting arm automatic positioning component, software component, which basically you as an operator press a button and then the arm will go to a predefined position. So if we want to develop this component as a safety element out of context, what the standards say is we need to information related to the system design and functional safety concept shall be assumed, considered, and validated. So it means that we will make some assumed safety requirements based on what we know where this component will operate. We will consider those assumed requirements when designing our component, and once this component is being reused in one of the systems, then those assumptions need to be validated in order for the component to be able to integrate it in the system. So to achieve this, we see safety contracts as means to do so, to capture what we assume, get the guaranteed behavior based on those assumptions, and then later on use the contracts to check if those assumptions hold when the component is reused. So when we look at these out of context reusable components, okay, they're developed independently of the system, but as well they're developed with configurable parameters, which means that they have different behaviors based on the values of those parameters in different systems. So that's why we have, as Stefano introduced, this notion of strong and weak contracts, where strong contracts are the ones that should be satisfied in every system, in every context, while the weak ones are those that are context specific. So only when required, they are needed to be satisfied. So if we take a simple example based on this loading arm automatic positioning component, then the strong contract could be that inputs are in predefined range. So you always expect the inputs to be in that range and the outputs as well. But then if we talk about weak contracts, those that are not supposed to always hold, then we go into something more specific and talk about the accuracies, for example, of the inputs, provided that the accuracy, so this weak contracts here say B1, H1, weak assumptions say provided that the angle sensor accuracy is this much and that the actuation deviation is this much, then I can guarantee that stop position of the arm movement is within this range. So we can have this range of different contracts for the different scenarios, let's say, for different contexts, based on the assumed requirements we consider when developing this component. But the difficulty here is, as well is how to derive such contracts, how to derive useful contracts. So we as well worked on means to do so. So the basic thing when we're capturing these contracts for reusable components, what we want them to have is safety relevant behaviors such that we can say, provided that this behavior or this contract is met, then the corresponding safety requirement has been met. So we need to capture behaviors relevant from the perspective of hazard analysis. If we look at the ISO 26262 lifecycle, there are different techniques we can use in hazard analysis and risk assessment. One technique that we have used for derivation of contracts is fault propagation and transformation calculus, because it's a compositional failure logic analysis technique, which basically means that we can consider failure behavior of components in isolation. So we can establish their failure behavior in isolation and then combine that behavior to calculate the behavior on the composite level or on the system level. And another thing, this FPTC technique is implemented in CHESS toolset as well. So we've looked into how we can get contracts out of this FPTC analysis. So let's say we have this out of context component. We specify its behavior in FPTC rules. For example, here we would have this big component C. Has two inputs, I1 and I2. It has one output, O1, and then we can say two rules for this component could be provided that I1 is late and I2 is late as well, which means that they're late. They come later than expected. Then the output O1 will not exhibit failure, which means basically that this component can handle inputs being late. But if both inputs exhibit value coarse failure, which is considered as a great value failure, significant value failure, then this component can't handle it, and it will cause late failure on the output failure mode. So if this is the failure behavior specified for this component, then we are looking into how we can get contracts out of this. What we see in these rules is some of the rules talk about mitigation behavior. So those that describe mitigation techniques within the component. For example, in this case, that the component can mitigate late failures. But some other rules describe behaviors that describe when the failure happens. So they're like a second example of the rule. So based on that, we can derive these contracts. One guaranteeing that the component mitigates certain failures, and another weak contract here saying, okay, this component will not be late, provided that environment does not provide value coarse failure on both inputs. So basically, this second contract is not always required to hold, but if in a certain environment you want this component not to exhibit late, then you will need to fulfill the assumptions here, the weak assumptions. Okay, having these contracts, then we need to see how we can use them for reuse and how we can use them to reuse safety artifacts and generate argument fragments from them. So a basis for that is the SafeCer meta model. So we did extension of this meta model and focused only on the out of context setting. What does it mean? Well, we consider a component as a composition of assumed safety requirements. So the safety requirements when developing the safety element out of context, the contracts that we derive to satisfy the requirements, where the contracts actually describe actual behavior of the component, and another thing is the support of contracts with evidence. So this component incorporates not only the implementation, but it's as well the safety behavior around it, which means the requirements, the contracts, and the evidence supporting those. Now, when we have this component meta model, then we need to see how to get out of this meta model, so these argument fragments that we were talking about. So basically, in those fragments, we would like to say that these requirements are satisfied. The satisfaction of the requirements can be established by looking into the satisfied contracts guarantees. So what do the contracts guarantee should imply the requirements. Contexts in which that clarify these goals and that put the whole picture on what the goals are about. We use their strong assumptions and weak assumptions. So basically something similar as in GSN assumptions, if we talk about goal structuring notation for representation of these arguments. And as well, evidence descriptions and so on. And then the solutions are actually the evidence that we use to support the contracts. So if we look at this what should an argument fragment for a contract or a component with contracts, what should it be composed of? When one thing is that this component is compatible with this particular context, that the allocated safety requirements are satisfied by the contracts, and then that we have confidence in the contract, that they are sufficiently consistent, correct with respect to the requirements, and as well complete. So compatibility with the context, as Stefano said, we check that all strong contracts are satisfied. That is the main initial thing. So if all strong contracts are satisfied, it means we can use this component in this particular context. Then with respect to the allocated safety requirements, we need to show that all contracts related to those requirements are satisfied, which means both strong and weak. And then we need to as well show that these contracts are sufficient to show as well that the requirements are satisfied. And then finally, we need to have confidence in the contracts. Some of this evidence about the contracts can be automatically done. We can check them for consistency, for example. But some of the evidence, for example, sufficiently complete, then we need to provide things like testing or simulation evidence or something similar, anything that can tell us that this contract is sufficiently complete, that is, that we haven't missed some important assumptions that imply the guarantees. Okay, so this is how the argument should look like. And let's see this now on this loading arm automatic positioning example. So when we're developing this and we assume out of context when thinking about scenarios in which this will be used, that the assumed hazard to which loading arm automatic positioning can contribute is unintended arm movement, especially during high speed, when the vehicle is moving in high speeds. So we don't want then that automatically just arm starts moving. So assumed safety requirement for that is that during high speed, the arm should be disabled. So if we have a contract, something to say that ground speed should be between 0 and 200. This is in kilometers per hour. And then there is a parameter of this component saying ground speed limit, which is up to 20 kilometers per hour. So the guaranteed behavior of the component is when the ground speed exceeds the ground speed limit, then the component will go to default output or disabled output, where it will say that it's not active and it will return flow, which is the movement of the arm, to 0. And we attach to this contract some strong, some context statements and evidence supporting this contract. When we have this, then we can generate argument based on what we said that an argument should look like. So just to see a fragment from that argument here. So if we take a look at the first top claim here, that the contract is satisfied with sufficient confidence. So we're covering here only the third part of what should an argument consist of. So this sufficient confidence in the contract is implied by that its assumptions are sufficiently satisfied by other contracts. That's number one. And then that we have confidence that the contract is sufficiently complete. That is, that we haven't missed any assumptions. So when we go on the side of assumptions, then we go for each of the assumptions in the contract. We need to show and point to the actual contract that satisfies that assumption, and we can as well point it as an away goal, saying this is okay, done, and covered in another module. And this is a GSN representation, I forgot to say, of the argument. And then once we have covered that all assumptions of the contract are satisfied and we are confident that they're satisfied, then we need to cover that the contract is sufficiently complete, and that means that we haven't missed any of the assumptions. And that we do in the second part, saying that contract is sufficiently complete, and we attach solutions to those goals. So this is an example of how we can get an argument fragment from the contracts and the information related to the contracts. So we did this on this loading arm automatic positioning. We reused this component. We developed it as safety element out of context. We attached contracts to it and evidence. We reused it in 2 different systems. These 2 systems are modeled in chess both. And then we derived some arguments for those. So if you look at these arguments, we can see that the one part of the argument is the same in both cases. And that's the part that's derived from the strong contracts. We consider them common between the different, basically between all cases in which the component can be derived, because strong contracts should always be satisfied, right? But the second part varies between different systems. So that part is system specific. It's basically composed of small fragments for each of the satisfied weak contracts. Since not all weak contracts need to be satisfied in all systems, this second part is specific to each system. So it includes certain commonalities and variabilities between the different products of the family of products, of product line, reloaders. So basically with these weak contracts, what we can get there is, for a safety element out of context enriched with them, we can get different context-specific argument fragments that include only relevant information for that particular context, filtering out the contracts, the weak contracts that are not relevant for a particular context or for a particular product, making the argument clearer in the end. Okay, so that was the presentation on the generation and reuse of argument fragments based on the safety contracts. If you have any questions.
Just a question for the contracts. Is it tool supported?
Yes, you can specify them in chess toolset because it's integrated with OCRA as well.
Okay.
So yeah, not fully, of course, because there are certain differences between the implementation with strong and weak contracts and those with ordinary contracts, let's say. And I don't think we have currently implemented these parts in chess with generation of arguments or connecting evidence and so on. But most of the things that we talk about, they can be cast to OCRA, let's say, and used through OCRA. But I think we can check as well with Stefano later on from FBK on their example. We've worked as well for the generation of argument fragments. We as well worked on generating argument fragments from FPTC directly. And then the next step, and we have that part implemented, but the next step would be to go and implement that part from safety contracts to argument fragments as well.
And the tool for using the arguments, did you implement it, or is it based in another one?
So the argument part that we implemented is not within chess, but so we generated arguments in SACM XML format, which can be imported in different tools, such as DCASE, for example, and ASTAC, and so on.
Okay.
Okay. If we don't have any more questions, then we can continue with the next presentation from FBK.
I just managed trying to put the presentation mode. Okay, I have some strange appearance here, but I hope you can see my slides. So just to put the slides in the context, here we are talking about an instantiation of the SafeCer component model that is supported with formal methods. Compared, for example, with the contract we have seen before, they are restricted to a specific syntax and semantics. So you lose a bit of flexibility and you gain full to supporting with formal verification techniques. So indeed, the context here is really the analysis of the system architecture enriched with contracts. Contracts are able to support the modeling of the system in different aspects. First, it can be used to analyze the system architecture while this has been developed, so that you can get early feedback during the development process when you don't have yet the implementation of the final components, and you have just the architectural decomposition, and as long as you decompose your system into subcomponents, you can enrich the components with contracts and check if such decomposition is correct. The second motivation of using contracts is to perform compositional verification so that you can analyze the final implementation of components in isolation based on the contracts of the components, and you don't need to analyze the composition, since this has been already considered in the analysis of the contract refinement. And finally, if you have existing components that have been already verified against some contracts, then you can have some assurance on the reuse of such components by checking if the contracts of the existing components correctly refine the contracts specified in the system architecture. So I will go more in details of this framework that we have. Please interrupt me at any time. I will try to be as brief as possible, and I think if there is interest, we can have a different training more focused on the tool in a different phone conference. So the components are described with yes.
Stefano? Sorry, yes. I see the first slide of your, still the first slide of your presentation. So maybe is the problem only for me, or?
Can you see my? You cannot see my slides.
The first one.
Yeah, for me as well. It was the first contract-based approach.
Well, it's the first one.
Yes.
Okay, you cannot see. Yes, indeed, I have some slides here. Oh, okay, maybe I can try it like this. Just I will not use the presentation mode, otherwise I have some problem.
Okay, thank you.
Now you can see the second slide, right?
Yes.
Okay, sorry about that. So the components can be seen as a black box described with the interface in terms of the input and the output ports that define the boundary of the components. The boundary with so whatever is outside is the environment of the component, and whatever is inside is can be seen as the implementation of the component. And the semantics of these components is described with traces that are also called execution traces. that describe the evolution of the component along time as a sequence of events or values that you can see on the input-output ports of the component. So when you open such black box, you can see the internals of the components, and you can decompose the components into subcomponents, or you can describe the behavior of if you are in a leaf of the system architecture, you can describe the behavior with a behavioral model like a state machine. So when you have a composite component like the one on the left top part of the slide, then the behavior of this composite component is given by the composition of the behaviors of the subcomponents. And you have different kinds of compositions that are available, synchronous, asynchronous, or they can synchronize on some events. And these are very important when you analyze the architecture with formal methods in order to define which is the proper semantics that you are considering. And generally, you connect the ports of subcomponents with connections that link, for example, input port of some subcomponents to output port of other subcomponents, to input port of other subcomponents, or to the output port of the parent component. So in these settings, a system architecture can be seen as an instantiation of a composite component that defines, based on the iterative definition of the composition, a tree of component instances. The properties here, so we have seen different kind of properties. We've seen a meta model talking about properties. We have seen some properties described with textual version. Here, the properties are meant to be mathematical expressions that describe how the behavior, how the system, the component can behave. So this property can say if an execution trace is good or not. They are also called assertions. And so we arrive at the notion of contract that can be seen as a pair of assumption and guarantee, and each assumption and guarantee are property defined in this way. So they are actually properties defined over the component interface, so they are restricted to the component ports, and they are structured into assumption and guarantees that play the same role as pre-post condition in the classic contract-based design that you can study in object-oriented programming. So when you have this kind of properties, then the guarantee is or better, the assumption is a property that must be satisfied by the component environment. So when you perform analysis, you will make sure that the component environment satisfies such an assumption. And the guarantee instead is a property that the implementation, however you implemented the component, if with other subcomponents or with a behavioral model, must satisfy provided that the assumption is satisfied. So this is, for example, in the green box, an example of assumption and guarantees written with the language of the tool support that we develop. So whenever you decompose a component into subcomponents, you have a contract specified at two levels of the hierarchy. And so you would like to ensure that this decomposition is correct based on the refinement of the contracts, based on the contract specified at the two levels. So we have a formal notion of this. We have a precise and rigorous notion that defines what this refinement means. What do we mean when we say that this refinement is correct? And this is given by the following. So the contract is correctly defined by the subcontracts if whenever we provide an implementation for the subcomponents that satisfy locally the subcontracts, then their composition will satisfy automatically the contracts of the parent component. And this is just one direction. On the other direction, we have to make sure that the assumption of each subcomponent is correctly satisfied by the environment created for this subcomponent. That is defined by the composition of the implementation of the other subcomponents and the environment of the parent component. So this notion of refinement holds for any possible implementation that you can plug inside the subcomponent and any possible environment that you can use as environment of the parent component. And so we have a tool support that automatically checks if this contract refinement is correct based just on the specification of this contract. And indeed, we generate a set of proof obligation. I will not go into details, but they are temporal logical formulas that are valid if and only if the refinement is correct. And we automatically check the validity of this proof obligation. So I will briefly mention the distinction between weak and strong assumption that also Irfan highlighted. In the tool support that we have, we explicitly only use a strong assumption. As I said, the assumptions are properties for the environment that must hold in order to use such a component. Weak assumptions are also supported, but in a non-explicit way, in the sense that weak assumption can be considered as the condition that you sometimes find in the guarantees when you say if x is greater than 0, then something is provided. If x is less than 0, something else is provided, and x is an input, and so this condition changes according to the context, but any value is valid. It's just that you will have a different guarantees in reaction. Instead, from strong assumption, the strong assumption must hold, must be satisfied by the environment, and so you have typically like assumption like the component must be provided with power, or the input must be in a certain range, otherwise the component cannot be used, and so on. So we have a tool called OCRA that provides these formal checks that I mentioned. It's publicly available here, so these slides are actually taken from a tutorial that is also available online. And it is a command line tool that takes in input a textual representation of these component interfaces. Similarly to, if you are familiar with the AADL, you have a textual representation of component interfaces and implementation, and the contracts as temporal formulas over the ports of components. And it has been integrated in CHESS, so that as Stefano showed in the first set of slides, you can specify contracts directly in CHESS attached to SysML components, and the OCRA tool is used as backend. You don't see, actually, you don't need to call OCRA. You just use the modeling features of CHESS, and press push button. You have a push button techniques in order to get the verification results. So I will skip other details about the language because I'm already covering my time slot. Just to mention that the tool provides some results for each proof obligation, detailing if the proof obligation has been valid, has been checked or are not valid. In case of failure in the refinement, there are provided some counter examples, some execution that shows how the contract refinement is failing. And we have also some features developed in SafeCer in order to provide fault trees from the contract specification, automatically injecting the contract refinement with failures that represent the failure of components or environment to satisfy respectively the guarantees and assumption, and we automatically generate the link, the dependency that exists between the failure of a composite component and the failure of the subcomponents. And this dependency automatically provide a fault trees that shows the relation between failures of in satisfying assumption and guarantees specified on the components. And I would stop here, and I would be pleased to answer some questions, or we can move to the next presentation. Okay, so if you don't have questions, if you have questions, you can also contact me by email, and as I said, we can have some tutorial. Some real tutorial more specifically focused on the tool support. Thank you.
Thanks. And if we don't have any more questions, then we can start with the next presentation. Let's see. So next presentation is by Barbara. You can see the slides.
Can you see the slides?
Yes.
Yes.
Thank you.
Yes.
So, I'm Barbara Gallina from MDH, and I will be presenting process lines, assurance case lines, generation, and reuse. So, first of all, I will introduce the context and the motivation. Then I will recall some terminology with respect to process lines, safety-oriented process lines. I will then talk about assurance case lines and generation and reuse. So, which is the context? If you are a process engineer or a safety manager, or anyway, if you are involved in the development of safety critical systems, you realize that you are in front of a pile of standards. There is a proliferation of standards, and this is a danger because we are moving from not few, but some 70s plus pages of documents to thousands of pages. So, for instance, the 078 initially was 67 pages, and now, if you want to be compliant with the entire pile of standards for example, integrated modular avionics, you have to face thousands of pages. So, there is a need to understand how to reduce such complexity, how to handle this complexity, and it is unlikely that we will succeed in preventing certification bodies from publishing new standards. So this is the context, and this is also in context with respect to SafeCer, because within SafeCer the objective was to co-develop the development process in jointly with the certification process, and also to go for a generic process. But a generic process, if you abstract away the variabilities, becomes useless. So the genericity is identified, but also what varies, and we'll show you in which way. So standards contain recommendation for safety life cycles. Very often you can see pictures depicting reference models for such life cycles. And here I'm showing to you what you can find in the standards with respect to the meta standards 6158, just pieces. The piece of ISO 26262 and also the piece of EN 50126. So meta standard, automotive, and rail. And as you can notice, just from if we look at the first row, let's say, of these three aligned safety life cycles, we can see that all of them require the concept to be defined. And if you keep on reading, you will find that there are other commonalities. And these commonalities are at the big box level. So before entering into the details with respect to what to do with these commonalities and how to treat the variabilities, let me recall what the process is, because the standards in reality does not necessarily impose a process, but suggest a life cycle, which is different from a process. It's up then to the process engineer to read the standards, read the methods that are suggested, read the activities that are suggested to achieve the objectives, and then organize all the activities, select the methods, establish the responsibilities within the organization, etc. So the process is typically defined as a set of partially ordered tasks that have to be executed to develop systems. Okay. So depending on the granularity, steps can be grouped into tasks, the tasks can be grouped into activities, activities into phases, and finally you have a process. But not only the breaking down of the work, but you also have to remember that you have requirements on roles, you have requirements on guidance, you have requirements on tools, etc. Then, if, like in this case, you have processes that exhibit commonalities, you may start talking about a process line, so a family of processes that exhibit commonalities. And I built on top of the notion of process line, which was introduced in 2009. And I introduced the notion of safety-oriented process line. Which is the difference here? The difference is that we had a special focus on safety. We were targeting safety standards. We were not only introducing a notion, but also a methodological support. And we have also introduced the notion of partial commonality, especially is of interest in case of processes, because if you compare structured process elements, like an activity that can be composed by tasks and in turn by steps, then you're interested not only to say, okay, they are equivalent, or since there is a little difference, you say they are different. You're interested in understanding which is the reuse potential. So you're interested in having a more fine granularity and determining the partiality in terms of commonality. So what we did was we have taken 3 standards. Then in one case we have taken 2 standards. In other cases we have taken 3 standards, depending with whom we were working with. And we have starting a comparative work, like in product line engineering. And what we did was comparing. So first of all, deciding for common terminological framework, and we took SPAM 2.0. And then we were trying to identifying activities, tasks, work products, guidelines, etc., all the process elements, while we were reading a portion of the standards, the same portion in the set of standards that we considered. And then we were starting identifying what was similar, what was different. And also what, when we were finding different things, we were also wondering, is this different relevant, or is just a terminological difference that can be, let's say, that we can overcome, because they maybe have used a different syntax. Is this ordering difference crucial? Is this grouping difference crucial? So we were asking ourselves all these questions, and then we were discussing with the industrial people. So, to overcome these terminological differences, for example, in some cases, we have decided to propose terms that were more abstract with respect to standard specific. Then, once we had these commonalities and variabilities that we had identified, we have started thinking it would be of interest to be able to model such family. And what is at disposal? Is there already a modeling language that could be used, possibly tool supported? And we have noticed that tool supported, ready to be used, perfect languages are not there. There is anyway SPAM 2.0. There is another language that currently has no tool support, which is called vSPAM. And since there was no tool support and we wanted to be pragmatic in SafeCer, we considered the SPAM 2.0. And because also we had the coverage and the tool support with respect to the modeling elements we were interested in. And we noticed also that we had, even if not perfect, the support to model variability. And as you can see in this slide, a process element can be considered a variability element. And then, according to the variability type, I can distinguish in which way the process element varies. If it is an A, it means that it does not vary, so it is a commonality. Then there are other ways in which it may vary. For example, it may vary because a process element contributes to another one by adding something, for instance, a new step. So, but we were also interested in highlighting the safety concerns. So, for this reason, we have thought, but we have not used in the tool, we have thought how SPAM 2.0 could be extended in order to highlight the safety aspects. For this reason, we have thought of decorating process elements with safety hats, which could have different colors according to the criticality level of the elements. And it's not only a question of concrete syntax, but we were also working on at the metamodel level with respect to SPAM 2.0. So we were thinking of having different safety levels. Then we were targeting the 178C, and we have noticed that there is a very specific terminology, for example, for the work products, that they have plans, they have standards. They also have, with respect to activity, very specific activity, checks, review, audits. So we were trying to highlight what is really safety specific to extend eventually SPAM 2.0 towards this direction. So, but to be pragmatic again, we left this extension on a side initially, and we moved to the plugin in Eclipse EPF that allows for process modeling. and we have decided to propose the following methodological guidelines. So first of all, the safety-oriented process line has to be modeled. So it means that a baseline has to be there. All the base process elements must be there. And for this, a plugin in Eclipse should be defined. Then once the baseline is there, it can be reused by specifying standard-specific elements, process elements, and then via the delivery, these processes can be configured and derived. So we had different levels in these base lines. We had all the process elements that were fully reusable, those that were partially reusable, those that were optional. And we were then defining when the variance with respect to the specific standards. And we were considering variance at two different levels. Variants that were at the standards level, but also variants that were company specific or even project specific. So here it's when you within EPF, once that you have the complete baseline, you can then configure and deliver your single process. Now, if you have a model of your process, or if you have a model of your process line, you can think of then using GSN, for example, or claim argument evidence, which are both, let's say, concrete syntax for SACM, the Structured Assurance Case Meta Model, another OMG standard for arguing about safety. You can think of using, for example, GSN to argue about process compliance. And the reason why among CAE and GSN we selected GSN is that GSN has been already extended to support the product lines, and also we can use these modeling elements for process lines, because you have the alternative, you have the optionality, so there is the support, even if not perfect. So again, then we put on glasses with respect to lines in order to see families all over the places. And not only we see the families among the processes, but we start seeing the families with respect to arguments that argue about process compliance. And we also use model-driven engineering principles. The methods that we suggest is as follows. Either you work at the line level and you engineer the domain, so all the process elements, and then from it you derive an assurance case line semi-automatically, or from a line of processes, you derive in EPF the single process, then from the description of the single process that can be exported from EPF Composer in a XML format, you can use that input to generate semi-automatically a process-based argumentation in GSN. So behind the scenes, there are model-driven model-driven engineering principles. So, but to work at the line level, we are not ready yet. We can do that on paper, because the extension for safety-oriented process line in terms of languages is not there, and also the extension in SACM for modeling in GSN for meta modeling in terms of optionality, alternative, etc., is not there. So what can be done, again, to be pragmatic, is that we consider as a meta model SPAM 2.0. We consider as a meta model the current version of SACM. We model a process in compliance with SPAM 2.0, and from such model we use model transformations. We have rules, and we can generate semi-automatically a process-based argument. An example that is on paper but has been also implemented is if you have a task, a simple task that is related to hazard identification with a role that is the responsible of the identification of the hazards. You know that you have used the FMIA package to perform hazards analysis, and you know which is your output, and you know which FMIA template you have used. You can always think of generating semi-automatically an argument about that, which is in compliance with a specific standard. And of course, this argument could be improved in various ways, but what we have shown is the possibility to do this and the potential that we already are supported. So it's a prototype solution. Then, in cooperation with WIF and AIT, we looked more specifically into automotive standards with Robert also, who we probably present together with Helmut. We have looked into automotive SPICE, ISO 26262 and IEC 6158. We have looked for commonalities and variabilities again. We have extended the approach of safety-oriented process line engineering, modeled it in Eclipse. Then we had as export an HTML for human readers, but also XML for to be read by machines. Okay, but and we wanted to let's say exploit the XML format within WEFACT, but this was not the exploitation was actually performed, but not automatically. So we have translated manually the XML format into WEFACT, because WEFACT also has support to model processes. Then from WEFACT, an initial implementation was achieved in order to generate automatically a GSN goal structure, and then to render such goal structure in DCASE. So with respect to future work and exploitation of this background within AMASS, there is already a post-SafeCer work that is extension of safety-oriented process line engineering towards...
Yeah.
Pardon? So there is already an extension of safety-oriented process line engineering towards security-informed safety-oriented process lines. And we are currently cooperating with Newcastle University, as Irfan said before, to implement a model transformation aimed at generating argument fragments. And such implementation are also expected to be adapted and integrated within the CHESS toolset and the continuation of the work within WEFACT. So I'm done. I thank you for your attention, and if you do not have questions, we move to the following presenter. Let me know.
Thank you, Barbara. I have a question.
Please.
Did you have you mentioned something about SPMM2, right? But EPF is only covering supporting.
80%. EPF covers 80%. EPF is not SPAM 2.0 implementation. Okay, they have a different meta model, but they guarantee 80% coverage of SPAM 2.0. Okay. And so for meta modeling, we are using and we plan to use the only open source solution that is currently available, so EPF. And we trust that 80% is really there. And the coverage actually is increasing because EPF is going to be evolved. So and it's possible to interact more with people.
What are exactly the plans to evolve EPF?
So
because
I'm
not being maintained, right?
Pardon?
EPF is a tool which is not being maintained, as far as I know.
I don't know if it is not
for an old version of Eclipse.
I'm not so sure because there was an update while we were working for SafeCer, and more recently I haven't checked, but I don't think that this project is concluded. And but anyway, imagine that EPF cannot continue or cannot evolve. There are non-open source solutions, even if at the university we have not bought any license to go towards tools that are supporting SPAM 2.0, okay, but not for free.
Okay, but this is if you use SPAM as a language, right?
Yes.
Have you evaluated at some point other language like BPMN, for instance? Because BPMN is a process language which is more used currently in industry.
There are pros and cons for both. Actually, in some industry it is used more because since SPAM 2.0 is bigger, some industry consider this language scary, okay? But it is it depends. It depends on the industry also, because BPMN was introduced mainly for business processes. So,
okay.
But anyway, they are equivalent. It's not that because in the publications I also say that SPAM 2.0 is an opportunity. Is one of the process modeling language. Then, if you have understood how to proceed, you can easily translate, because our was a pragmatic solution with respect to project constraints and university constraints. Okay. Then, if you are an industry, I'm not knocking your door and imposing you to use EPF. I would suggest to use the process modeling language that you are already using, and then I support you and help you to implement our solution, our theoretical solution. I would not sell EPF to an industry now in its current status, but I would sell the approach. Yes.
Okay. Thank you very much.
May I also have a question? I have just thought about commonalities between your lecture and the previous one, and I see that we have some, say, functions on the one side and the processes on the other side. They both have some hierarchical level with lots of structure with lots of levels. I just wonder whether it would be beneficial, say, to try to merge those two approaches and describe the processes by using the contracts. Oh, that's it.
I'm not sure that I haven't. I'm not sure about your question. So could you formulate it again? So you are asking that there are many levels, right? Where are there many levels in the process in terms of structure?
Yeah, I mean, you said that there is some phase level, task level, process level,
yes,
and so on, and the functions in the previous lecture. They have also many levels, and they compose from the basic tiny functions to the more complex structure. So I see a similarity here.
Yes, yes, there is a similarity here. In fact, can you see this slide? So
if
I'm working at on this quadrant, okay? I'm working on this quadrant, and I'm trying to understand the structuring at the process level, okay? Then aligned with the process, there is the structuring of the argumentation with respect to process compliance, which is strictly connected to what? To the structuring of the system. Okay? So when you design your system, you design at the system level, but then inside you have to design the components, okay? And when you move from system design to component design, you are moving from single components development and system development. So also these are one box that is inside another when the integrators take care of integrating the different components. So you have boxes that are nested at the process level and boxes that are nested at the when you model your system, but you cannot just flatten everything. If this was your question, you can connect.
No, I just disregarded the y-axis. So I was just thinking about the process alone, without regard to the structure of this developed system.
Okay, so but you are asking, is it possible to flatten?
I was asking, is it possible to express the picture which is drawn in the XZ space to describe it by using the notation of the previous lecture? Would it be beneficial to have contracts of processes or of tasks and somehow compose them together?
Yes, you can. But we have discussed this internally. We have not done this yet because we were not ready in terms of joining the contracts in GSN. But you can, in SPEM 2.0, you do not have the explicit notion of contract, but you do have the explicit notion of process component. So it's possible to use the same approach, but still thinking of having components that are commonalities, let's say, process components, and process components that are optional, and others that are in alternative, etc. Yes, you can.
And may I ask you, when you discussed it, what was the reason why you stopped to think in this direction?
Human resources? the project was ending. We had no more human resources at the disposal. So the idea is to continue within AMASS. And also I had no other helpers digging into EPF to be able to understand how to, for example, let's say, model the extensions that we had thought to see if the process components are actually supported in EPF or not. So mainly time and human resources. This was.
Okay, thank you.
Welcome.
Can I add a comment on this? This is Stefano from FBK. So what I'm not sure to understand if the process that Vita has in mind is really the process that Barbara described in this slide, or rather a process that would be the object of the analysis and the assurance case. In other words, I think we have some previous works, or current works actually, in modeling and analyzing processes and procedures, like crew procedures and so on.
No, but
that anyway would be part of the XY dimension.
No,
And,
because I asked him, actually he was looking into development processes, because you can think that,
Yes.
okay, I'm the development, so you have different development teams. In big organization, you have the testing team, you have the architecture team, you have the requirements engineering team, and you can think of having contracts, okay, among the teams that establish who is going to produce what in terms of work products, and they define the contracts. So assuming that you provide this to me on time, okay, I will respect the milestone, my milestone related to my team, and I will deliver the work products for the design, because the requirement specification was there, etc. This kind of contracts. And these are theoretically supported in SPAM 2.0, not named contracts, but they are there in terms of compositional approach components, process components.
Okay, thank you.
Right? Okay, then I believe that time is over.
Yes.
And we should move to the next presenter.
Yes.
Thank you.
Okay. So next presenter, who will be presenting from AIT.
Yes, hello. This is Thomas. Good afternoon.
Hello. Okay.
Okay. So, can you see the screen?
Yes.
Yes, WEFACT? Okay. So let's start. Well, my presentation will be about WEFACT, and in particular about the DCASE editor integration in WEFACT for GSN, which has already been described a bit by Barbara in the last presentation. Well, I have quite a short presentation on WEFACT and the GSN integration of the DCASE editor, and then I would like to show a video, 6 minutes long, about what was done with WEFACT in different use cases and how it works, basically. I hope that works. We'll see it. And after that, Helmut Martin of VIF will present more details, particularly about how WEFACT was used in the HEY, the hybrid vehicle use case. Okay, good. The content of the short presentation will be a description of WEFACT, objectives, ingredients, the framework, the workflow. Then some specific features mainly the V&V tool integration, the documentation support provided by WEFACT, and a safety case reporter. And then comes the presentation about the DCASE editor and how it is integrated in WEFACT, import and export facilities for the GSM tree to communicate with the DCASE editor, and then the link with the different V&V activities in WEFACT. Well, objective of WEFACT. What is WEFACT supposed to do? It guides the user through a V&V, that's verification validation, and through the certification process. As you already heard, I mean, those of you who have not been involved in SafeCer, SafeCer dealt with safety, and also WEFACT was designed to deal with safety. On the recent developments go towards security, and we will see what we can do in AMASS for more multi-purpose assurance. WEFACT follows safety standards and defines a workflow which is driven by requirement for the generation of modular and incremental safety cases, again safety. WEFACT helps in identifying and carrying out V&V activities, provides so-called V plans or validation plans for controlling the V&V process. It supports full traceability because it's based on doors and its logic for tracing the requirements. And it checks the status of requirements and of the certification in the sense of that each part of the compositional safety case is known which status it is, and at the end you know the whole safety case is fulfilled. WEFACT also facilitates the integration of V&V methods and V&V tools, provides different interfaces to tools. I'll tell more about it later. WEFACT collects the documented results in a repository on the level of single V&V activities, on V-plan level, also in respect to the requirements. So the status of each requirement can be seen at any state of the project. What belongs to WEFACT? Well, WEFACT is a window tools based on doors. Much of WEFACT is currently implemented indoors and uses doors logic and doors dialog box, etc. But we are now considering to migrate towards an Eclipse plugin, which is more flexible than and should offer facilities also for those companies which do not have doors licenses. In the current version, WEFACT relies on the doors database. It provides some user guidance. It uses V&V tools to test or analyze or whatever certain artifacts under test or under whatever. It uses a data document repository. In the current version, it's connected via FTP, but this can be altered. The central part of WEFACT is this management part, the yellow rectangle, which contains the definition of the workflow, the dependencies between V&V activities and the requirements, and so on. As mentioned, we can connect to several tools. One of them is the DCASE editor, which I show later. WEFACT is more or less a framework which supports the safety case as a central goal. It will probably now support more when we extend it within the AMASS project. The safety case is based on V plans whose execution provides results which can be true or false, positive or negative, and provide the evidence. And the collection of all evidences is the validation report for the safety case or for the safety certification. WEFACT uses artifacts. That means that, for instance, software modules. It is based on standards and other sources, e.g. coming from domains, company-specific practices, and the like. It can use external tools and internal tools, and it delivers feedback to the developer in case some V&V activity has a negative result, test case fails, for instance. But that's main functionality of WEFACT. It shows a bit more in detail the WEFACT workflow. I think we are quite advanced in time, so I suggest to skip this very, very detailed slide. This slide now shows the integration of WEFACT in the SafeCer process. We have the process model already mentioned by Barbara, which more or less represents the safety life cycle of a system and contains, of course, different steps from the concept of a hazard and risk analysis to development and validation and etc., etc. And WEFACT, of course, uses a kind of internal model, which is just a mapping of this process model into steps which are done within WEFACT. WEFACT starts from requirement definitions. Then the V-plans are developed, means which activities can prove that the requirement is really fulfilled. Then the V-plans are conducted, they're performed, and deliver results, pass or fail. And all these results from V-plans are collected and provide the evidence for the safety case or for the safety certification. As I mentioned already, it's all focused on safety, but we will try to include security and within AMASS also other quality attributes. The integration of tools in WEFACT is used for testing, analysis, and whatever step is needed to prove that some requirement is fulfilled. We can distinguish 5 different kinds of tools. An internal tool is some tool that started directly from within WEFACT. One example could be a checklist, which could be some table in Word, which is directly called from WEFACT. We use this as an example for the hazard log in the railway domain in SafeCer. Next category of tools is manually executed external tools. The DCASE editor is one of those tools. I will show later more about it. Then, well, a tool can also be executed automatically external. OCRA, for instance, was such a tool. It was started externally by a tool server, but triggered by WEFACT. Another relatively novel kind of binding is the OSLC, automation provider. It was also used in the use case, data simulator use case. The tool started via OSLC, automation provider. And finally, we have the totally external test bench. An example would be an electromagnetic interference hardware test bench, which cannot be coupled directly, of course, because there must be some operator who puts the device under test into the machinery and measures it and imposes some electromagnetic field, etc., etc. So this is quite separate then. In any case, of course, the results are fed back into WEFACT. Yeah, documentation support is provided by WEFACT, of course. The idea is there's a certificate that's on top here, or a safety case. And of course, you get validation reports as an input for the safety case. And the validation report comes from different kinds of detailed reports, review reports, formal proof reports, system analysis reports, test reports, etc. All these are collected in the validation report. So the idea of WEFACT essentially to keep an overview of over all kinds of reports and all kinds of validations which are needed to have a final proof that the system is safe. Here we see a short example for a validation report. You see well, there are different V-plans executed and for process independent model, processor independent model, I think, yeah, the V cascade model. And at the end, you get out some report in a defined format which you want to have. And of course, one of the fields must be the result, pass or fail. One of these things here must be pass or fail. Yeah, here it is. Yeah. Okay. There we go on now. There's also a tool called Safety Case Reporter, which shows the status of a safety case. We see yellow, green, and red buttons indicating the status of some process, if a requirement here is approved or not yet approved. If it's closed, then it's green. If it's only proposed and not even approved, and of course not closed, it's red. And at the end, when some simulation is done or some testing is done or whatever process is done in the V&V activity, at the end you get also the results for the single parts of your system overall test plan, so to speak. You see here some are just running, some are completed, some are yet open, not yet ready. Means something is missing, for instance, test data not available yet, the tool is not available, whatever is yet missing for performing the V&V activity. Well, a short summary of the features of WEFACT. WEFACT supports V&V and certification process. It relies on standards, COTS components. concrete IBM rational doors, but we want to go towards Eclipse, as I mentioned. WEFACT integrates with external systems, tools, and processes, and it provides support for establishing safety cases. Now we come to the DCASE editor integration. Well, how is this done? First, you draw your GSN structure in DCASE editor. Could also do it the other way around, of course. Yeah. Normally, you start drawing your GSN argumentation in DCASE editor, then you import it into WEFACT and integrate it within the WEFACT database and link it to appropriate V&V activities and the requirements in WEFACT. So it's a basic process and not a bit more details about this. The DCASE editor is a tool which comes from Tokyo University, used by University of York. To our knowledge, the most recent version is not very new, so it's a matter of discussion, I think, if you really want to continue using DCASE editor. The last version stems from 2013, I think, and is not compatible with the latest Eclipse framework version, so we should discuss this somewhere. In general, the DCASE editor is a free Eclipse plugin, a typed assurance case editor. It uses in WEFACT the GSN nodes menu to collaborate, and the DCASE editor exports two files, an XML file for the logical structure of the GSN argumentation. This is used by WEFACT, and the layout file, which is used only by DCASE editor. As mentioned in WEFACT, these GSN nodes coming from a DCASE editor are linked with requirements, with VPlans, with V&V activities, thus implementing the proof for the single solutions in the GSN structure defined in the DCASE editor. Import-export. Sorry about that. I didn't delete these lines. That's a bit old. It's already, of course, implemented and ready. Yeah. This is a screenshot of the DCASE editor. You see the GSN structure and the menus to edit this structure. The DCASE editor provides functionalities for automatically layouting the the GSN tree in a reasonable manner, but you can also edit it manually, the layout. So integrating a DCASE editor GSN structure into WEFACT means you get from the DCASE editor the goals and the solutions, and of course in between the strategies and the context, etc., etc. And you import it in WEFACT, and then you link it to requirements. Normally, a goal is linked to a couple of requirements. It can also be a one-to-one relation. That depends. The solution is linked to V&V activities. Can be normally with several. And of course, the V&V activities are linked to the requirements. It's traceability, which is anyway implemented in WEFACT. So, as mentioned, goal and solution created in the DCASE editor. WEFACT adds the rest here. These are the two files which are created by the DCASE editor. The layout data are used only by DCASE editor. The model data which are imported in WEFACT, which have XML formats, more or less. Yeah. In WEFACT, we have the DOORS database. The model data from the DCASE editor are imported into WEFACT, and you can modify the GSN structure in WEFACT. You can even add nodes or solutions or whatever you want. You can just modify the GSN tree, not in a graphical manner, but in well, it looks like this in the table. Yeah, you can add nodes, etc., and link them back here now, and you can re-export, of course, what you have changed in WEFACT into the DCASE editor in XML format. DCASE editor can read the file, and in case you have added new nodes or new strategies, whatever, DCASE editor will again add additional layout information which is necessary for the new items added by WEFACT. So we can really hand in and out the GSN tree between WEFACT and the DCASE editor. Well, here's a bit of details how the data are exchanged. Nodes and args have unique identifiers, so we can really hand them between WEFACT and DCASE editor. As I mentioned, the original layout can be found in the DCASE editor when re-imported into DCASE editor. The links to the requirements to the VBlend, of course, are maintained within WEFACT. When we modify the GSN in DCASE editor, we can re-import it in WEFACT, and we still have the V&V activities and the requirements associated with the GSN structure. So generally, it's quite compatible, and yeah, I think DCASE editor gives some information about changes that have taken place in between. If new nodes, etc., are added in DCASE editor, of course, their respective information linking to requirements and VBlend must be added in WEFACT. That's clear. Okay, in WEFACT, the GSN node menu in the WEFACT menu is used for accessing this data. You see you have here the goals and the strategy solutions, etc. You can edit all that. You get into, well, I think we are quite advanced in time. I skipped these details, how it's implemented in WEFACT, and just show a little bit some dialog boxes. So the goals can be edited here, the adequate descriptions. With some responsible person. You always have to add responsible persons in WEFACT. Who's responsible for this goal. Goals are associated with this menu here, with requirements, and with that one with V&V activities, the solutions. You can create claims and contexts. All that is provided in separate dialog boxes here. And of course, for import and export of the GSN structure in XML format, you have special dialog boxes. If you look here, if you import a menu, if you import a GSN structure in WEFACT, you can say I create a new module. That means you will get the entire new structure from the GSN in WEFACT, or you update the current module, then you just integrate the changes made in the DCASE editor in WEFACT. So it's quite flexible here, the tool. Okay, so that was about something about WEFACT and the DCASE editor integration. Further work, which we intended to do now, well, we are adding security features in the EMC Square project and plan now a migration from Doors to Eclipse as an Eclipse plugin. And in AMASS, we expect now the extension towards multi-concern assurance, much more than only safety. Many attributes can be treated then. Well, I've also prepared a video. The video is actually publicly available on the WEFACT homepage in the AIT website. It shows the use in the hybrid electric vehicle powertrain use case, about which Helmut Martin will tell a bit more then. And the SafeCer and process line demonstration, as already described by Barbara, model-driven SafeCer, model-driven safety certification. So I hope the video works now. I hope I get feedback from you if it actually does. Yeah. The problem is I have no sound now. I don't know why. Can anyone hear something? I suppose no.
No.
Thomas, we can hear you.
We can hear you.
Okay. So obviously my sound has been captured by.
No, but we cannot hear the video.
Yeah, but
I see. Yeah.
in the worst case, you could always, so the link is there, and recording a recorded video is not necessary. I mean, it's already recorded.
Yeah.
So,
Yeah.
and I also had provided that link. You are providing that link also. So if we do not succeed in video recording an already recorded video, you are not missing that much.
Okay, I suggest if you are interested, just click this link here in the slides. I provide slides on the AMASS website, on the CN, and you can just hear it. Obviously, it does not work in parallel to the GoToMeeting, because GoToMeeting captures the sound. I don't know. Okay, so thank you for your attention, and I would like to hand over to Helmut Martin now for more details.
Helmut Martin is not available. I am Robert Bramberger from the Virtual Vehicle Research Center. I will present the final part of this presentation.
Okay.
Can you see the slides?
Not yet.
Not yet.
Now it seems, yeah, now it's okay.
Okay. It will be a short add-on on the presentation of Thomas. I think I can go through within 10 minutes. And I will show something about the DCASE editor and how we use it in EMC Square project. For the motivation, in the SafeCer project we have created this safety-oriented, developed a safety-oriented process line together with Barbara, and the ISO demands safety argumentation between safety goals, safety requirements, and the safety work products. And this is what we want to cover in the EMC Square project, based on the safety-oriented process line elaborated in the SafeCer project. I will not say too much about the process line. We have had the presentation of Barbara. Only these three rectangles, very short. We start with regulations. We have a process development. Then we have process management and the artifact repository. And our approach in the EMC Square project is concerning a methodology to provide argumentation based on GSN. And our approach is the argumentation is part of the process. We have a safety project-specific process, and this process has already the argumentation methodology included. We have defined two different argumentation paths. One hand, we have the process-based argumentation, and on the other hand, we have the product-based argumentation. First, the process-based argumentation is directly related to the process. It is suitable to argue that all requirements concerning the engineering process are fulfilled, and in the end, it supports process and functional safety audit. In other words, we provide argumentation about the process for this audit. On the other hand, we have product-based argumentation. The product-based argumentation is intended to document product-specific decisions within a project. In the end, it supports functional safety assessments. Okay, this is quite short about this process argumentation. We are using GSN. GSN consists of some base elements. These elements are shown on this slide. We can create goal structures. A simple goal structure here on the right side. At the top we have a goal. We have a strategy which leads to sub-goals. Each goal can have a special context and some assumptions. And at the bottom we have a solution.
And this solution is directly related to work products. These work products are the evidences for the argumentation. Here, the DCASE editor is used to create these goal structures. Thomas said something about this. I will introduce these windows. In the middle, we have the editor window. Here you can create your goal structure. On the right side, you have the elements provided by DCASE. At the top, we have the basic elements from the GSN standard. In the middle, we have some DCASE-specific elements, and at the bottom, we have the linkage elements. On the left side, the Project Explorer, it is used to manage the project on file level. And the last window, the property window, here you can display some properties for a element in the editor in the middle. This example is a process-based argumentation. We have a goal at the top, we have the strategy, a sub-goal, and then we have evidences. It is created with DCASE. And you see on the left side these green elements. These are modules. This is a special feature of the DCASE editor. These modules are used to keep these goal structures simple. If I zoom in to these two modules, you can see the hidden elements. Yes, and you can use this for bigger or for larger goal structures to keep them simple. Second example, this is for product-based argumentation. It's quite similar from the first view. Only the content of the elements is different. Short conclusion of the DCASE editor: it supports basic GSN elements. It supports modularization of the structure, but it does not support unique IDs. It does not support the implementation of undeveloped and uninstantiated goals, which is provided by the GSN community standard, and it has no direct linkage to evidence documents. This is quite a problem, because I think this is it would be a very interesting feature if this is possible. So we are going to improve our argumentation as our process and product-based safety and security argumentation in the AMASS project. And yes, that's all from my side. A short description about our activities and what we are going to do in the AMASS project. Thank you for your attention.
Thank you for the presentation. If we do not have any questions, then we can conclude this session. Anyway, the video will be located in the link in the SVN that I sent in the chat. So that's the Baseline Solution seminars for SafeCer session. And that would be all.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Bye.
Bye. Bye. Bye.